Let's go ahead and continue our exploration of cloud fundamentals, models, redundancy, and key providers. We're going to jump right back in, this time looking at data centers and looking at all the things that data centers provide. So data centers are physical facilities that house the critical infrastructure necessary for cloud computing, including servers, storage systems, and networking equipment. And again, I can't encourage you enough, if you ever get the opportunity as an IT professional or just as a consumer to go tour a data center, it's absolutely amazing how clean it is, the redundancy there, the power that's needed, the redundancy and power that's needed, all of the technologies that are running efficiently and all combined to create this seamless experience you have when you upload a photo via Google or use Gmail on your phone, whatever the case may be. So, they do serve as a main hub of cloud services, providing hardware and the software resources to store, process, and manage data at scale. And for some organizations, that scale is absolutely humongous. Can you imagine how many pictures, how much data Facebook stores for one user, and then go out and look at how many users that they have worldwide? So a key part of this is definitely redundancy, and redundancy refers to the duplication of critical components or systems within data. So we're not just talking about redundancy at the data level, we're talking about redundancy at the physical level, at the server level, at the storage level, at the power level. Everything in a data center is redundant. And I don't mean redundant times 2. I'm talking redundant times 3 and 4. And it depends how mission critical that data is, how many applications of redundancy are applied to it. For example, a typical data center will have what's called a 4-post networking infrastructure, meaning they have, 4 main powerful routers that each route traffic that are each up and working, but they could lose 1, they could lose 2, and still have enough throughput, between firewalls and switches and routers and all of it to keep that machine up and running, to keep the data center up and running. It is just absolutely amazing. Redundancy in the aspect of power. I think I did explain previously in a previous video that, the local Apple data center has, power, regular power. They have solar panel, just from a green standpoint, solar power from a green standpoint. They have backup power in the way of batteries. And then, of course, if all of that fails, they have generators that they can start up and run 24 hours a day to keep that data center up and running. Because remember, the data center is not necessarily just serving people in that area who also may be without power and thus can't access the data without their computer, but data from all over the world because of the redundancy. So keeping these data centers open and running and operational is hugely important, 24/7, 365, right? It ensures the continuous functioning even if one or more of the components fails. That's the key to redundancy. And of course, along with redundancy is the idea of disaster recovery. This is where we need to know that if there is this disaster, and remember, ransomware is a disaster, okay? There's a threat that is a disaster, that we can implement disaster recovery resources and plans, okay, so that we don't have to pay the ransom. But in this case, disaster recovery involves strategies and systems put in place to recover data and resume critical operations after a significant disruption. This could be a natural disaster. This could be a cyber attack. Okay. So again, one of the advantages for companies having their data in a data center and having that data redundant over multiple data centers is the idea of disaster recovery. Now, let me be very, very clear. Nothing beats a backup. Because if our data is stored in two places and both places incur a ransomware attack or are on our network and thus the ransomware attack has access to them, it's going to encrypt all of that data. So we do need to have a backup, and we have to have a means of restoring that backup quickly. Recently there was the CrowdStrike incident where we saw that Delta Airlines did not have a good disaster recovery plan and people trained to restore mission critical systems so that they could continue operations. All of that because of one patch? So never a good idea. Geographic redundancy, we'll look at this a little bit. I've got a map as we talk about latency that'll explain this as well. But, where data is replicated across multiple locations. So my Facebook data is not just stored in the Facebook data center in Prineville, Oregon, 20 miles away. It's stored in other data centers in case the Prineville data center were to go down or were to incur some sort of natural disaster. They happen to be near an airport. What happens if a plane, crashes into there? We've got to have that disaster recovery. We've got to have redundancy. So here's that example of latency. Latency refers to the time it takes for data to travel from one point to another. In this case, to my Facebook data needing to travel from my phone in Bend, Oregon, right, to the data center in Prineville, Oregon. So the closer I am to a data center, the less latency there is, okay? The less time it takes for that data to travel. Now, a couple things you'll notice about this map, and we'll just address these sort of as a side topic. You'll notice there's no data centers in California, for Facebook, and there's no data centers for Las Vegas and Facebook. They might have some small data centers now, but not major ones. And the reason for that is a lot of these states tax processors, which means you're taxed by the number of processing units you have. So imagine the tax on a data center with, 500,000 servers, each having a 24-core processor. That's a lot of money to pay. So consequently, we'll put them in states that don't tax processing, that give us tax breaks on the land, that have good power and access to the backbone of the internet, okay? But if I was in San Francisco, my data could be stored in Prineville. It could be accessed in Utah. Perhaps if I travel and for some reason I'm in New York for a month and I access Facebook constantly, it'll pick that up and it'll say, you know what, we need to move his data to Washington so that it's closer and reducing that latency. So let's look at a few of the major cloud service providers. Now, what we'll see towards the end is, when we talk about the big three, Amazon, Google, and Microsoft, they offer a plethora of services, where the other two we talk about, you'll see offer specialized services within the realm of their specialization. Okay, so let's start with Amazon. They were the first. They are still the largest. And their biggest claim to fame is this elastic compute cloud. It provides scalable computing capacity in the cloud, meaning I'm not having to have cloud resources for 100,000 hits to my website each month when it only gets 100,000 hits in November and December before the holiday season, okay? Thus, I'm paying for just what I'm using at the time, but the ability to scale, knowing that maybe I put out a new product or a service and I know I'm going to get a lot of attention on my web, I don't want to have to buy that service forever, that scalable service forever. So I'll, scale my web and I'll pay for just what is being used. That's kind of the key there. It's kind of like getting gas, right? So ES2 is the cornerstone of AWS's infrastructure. It's what brought people to the cloud, was that scalability, that redundancy, all the things that make cloud great. So extensive global network of data centers, again, reduce that latency, and preferred choice for enterprises of all sizes due to its vast service offerings and reliability. So, a lot of opportunities within cloud engineering as it pertains to information technology. Now, coming up number 2, and has yet to really take over the number one spot is Microsoft Azure. And what we see with Microsoft is the incorporation of virtual machines. Now, if you've ever done a virtual machine within a Windows server, you know how easy they are. And they brought that technology to the cloud. So thus, people could, in fact, bring forth their local instances of virtual machines and either move them to the cloud or create redundancy between the local machine and a cloud instance of that virtual machine for, again, redundancy, for disaster recovery, for latency, putting it in a data center closer to their customers, for example. A lot of great benefits here. And of course, obviously, they've implemented their productivity suites as well. So you've got, your Office 365, whether it's a corporate instance or a personal instance. You've got cloud storage where you can store stuff, again, not a backup, even though you may be doing redundancy as it pertains to everything in your My Documents folder. It's local on your computer, so you can use it locally without internet, but it's also up on the web, so it's not taking, as much space on your local computer. A lot of people today are looking at, reducing the capacity of disk space on their devices because they're storing so much in the cloud, they never use the disk space that they're buying. Okay. So again, there's some advantages there. Finally, that leads us to Google. Each of them sort of has their benefit. They have their key, their cornerstone. As we know, Google uses a ton of cloud. You've got a Gmail account, you're using cloud. Okay. If you're doing Google Docs, Google Sheets, Google whatever, Google Workplace, you're using cloud. You're leveraging cloud. And one of the things that Google really leverages is Kubernetes, which is an open source platform for automating containerized application development. So containers versus virtual machines. A virtual machine is just that. It's a machine. It has an operating system. It then has applications, services, files, whatever on top of it. Whereas, to keep this really simple, containers are sub-containers of a system. Thus, if we need a container that connects from a user interface to a database and we want to connect a lot of those, we can scale through containers. We create better security through containers. It does help with scalability. We can create specific containers for specific IoT devices so that we don't have one server servicing a lot of things. We have one service with a bunch of Kubernetes containers, that provide that deployability, manageability, and scaling. So that's kind of the key there as it pertains to Microsoft. Now that does bring us to IBM and the cloud. And when we talk about IBM, we talk about advanced, highly secure services. So IBM makes their way into the cloud first and foremost with AI, blockchain implementations for companies, as well as security for specialized organizations, that require more stringent regulatory requirements, if you will. Okay. So, that's where IBM with IBM Watson, machine learning, large language model processing, as well as those industry regulations. So that's where IBM makes their mark, if you will. Finally, there's Oracle. And if you haven't heard of Oracle, then you're probably not using a database. And so Oracle databases, are huge. Oracle has the Oracle Autonomous Database. It's a self-managing, self-patching, self-securing database. Now, it doesn't mean it doesn't need work. It doesn't mean it doesn't need somebody to administer it. It just has some capabilities built in that make it a highly secure database. And we see these used in SAP Enterprise Resource Planning systems, for example. So their cloud instances are really designed for a lot of data transfer, scalability, security, database performance, okay, as well as some sustainability, according to them. So, focus on performance, security, top choices for, basically Oracle technologies. That's the key here. So they're making that money off of their services. So that's going to do it for part 3. In part 4, we're going to come back and we are going to take a look at securing the cloud. So we're going to jump into fundamental cybersecurity principles as it pertains to the cloud, as well as best practices for cloud computing. I'll see you then. Take care.